Welcome back. So in today's lesson, we're going to be taking a look at section 2.3 on lines. So with our lines, there are multiple things that we can take a look at, and 9 different objectives listed in our textbook as far as what we want to take a look at today. And so I'm not going to read through all of those. You can take a look at those, pause the video if you want, and then come back through. But the first thing we want to take a look at is what is slope? So by definition, slope is the change in the y values divided by the change in the x values. It's a ratio. So officially in our textbook, they're going to say, let p equal the first point x1, y1, q equal the second point x2, y2, and let those be two distinct points. Distinct points mean they cannot be the same thing. So if I'm going to go ahead and try to draw that out, let me go ahead and put a point down here. Let's call this point P. We'll call that point x1, y1. And let's have another point over here. Let's call that Q. And we'll call that x2, y2. Two distinct points because they are different. And what we're saying is the slope of these two. So if I go ahead and connect these with a vertical component and a horizontal component, okay? So I've got this item here. Kind of make a right triangle out of this with a vertical and a horizontal. We know that's got to be perpendicular there, so that's going to be a right triangle. What we would have then is that this length here is going to be the change in y values. We're only going up and down. So the change in the y values is y2 minus y1. And then the horizontal component over here is because the horizontal, we don't have to worry about any of the y values, is x2 minus x1. Frequently then, what we say then is the change in the y values here is what we call the rise. How far up and down are we moving? And then the horizontal part is called the run. How far across are we going? So this idea of slope, m, okay, and look at the abbreviations that we use for mathematics. A for area, L for length, W for width, then we end up M for slope. And it doesn't quite make a whole lot of sense on why we use M for slope. But for some reason, years ago, before any of us were around, the mathematicians decided to use M for the French word for mountains, like slopes, the French Alps. Monterre is what I believe that comes from. And so this slope here, M, is the abbreviation for slope. Multiple different ways that we see that written. We see that written in our textbook example, y2 minus y1 over x2 minus x1. That's the typical thing that we see. Also with this caveat up here, that the two x values cannot be the same, because if they're the same, x2 minus x1 goes to 0, and dividing by 0 just doesn't make any sense mathematically. Other ways that we can see this that we might remember from other math classes is this is also the rise over the run. Another way that we might see this written is triangle with y and a triangle with x. And that triangle really stands for is the Greek letter delta. So it looks like a triangle, very true, but we don't say triangle y over triangle x. We say delta y over delta x. And what that means then is the change. So the change in y values over the change in x values. And so whichever one you want to use, rise over run, change in y over change in x, delta y, delta x, the official formula, y2 minus y1 over x2 minus x1, all those things just talk about what we're taking a look at in our original points up here. What is the change here in my y's compared to what's my change here in my x's? So that overall is the main theme of slope. It's a ratio. And then we can take a look at all kinds of things with these ratios. So let's take a look at an example of slopes, the ratios of how steep we are as far as different coordinate points. So I'm going to go ahead and add a grid to my background. Oops, let me go ahead and use the line tool here. I think that line tool might be a little bit easier. And let's see, so all of these are going to go through the same point P. They're all going to go through the point 2, 3. But what we're going to do is we're going to change the value for Q, the second point. And we're going to see what the slopes are going to be through each of those. So let's see, I want to go through the point 2, 3. So let me go ahead and, let's see, mark some things off here. So there's 1, there's 2, 1, 2, 3. So there's point P. So there's point P. Let's see what else we can come up with. So the first Q, okay, is going to be -1, -2. So -1, -2 is going to be down here. So there's going to be Q1. If I go ahead and connect those with a line, so if I connect those with a line, that's the line I have. And then we can go ahead and take a look at that and say, okay, well, what is the slope? So I can say, okay, let's calculate the slope. So my slope of P to Q sub 1, okay, is going to be my change in my x coordinates. So, excuse me, it's changing my y's first. So rise over 1, run. So I've got -2 over 3. So -2 minus 3. And at whichever point I start with, that's going to be my coordinates here. So if I'm letting P be my first point, since that's the first one listed, Q, whatever it's 1, 2, 3, or 4, is my second point of that pair. So if I'm doing line 1 here, okay, P is my first point, Q1 is my second point, so that's why I'm using -2 minus 3. And if I do my x coordinates, the x sub 2, so the second x, so -1 from Q1, minus 2. So -2 minus 3 is -5. -1 minus 2 is -3. So overall, the negatives cancel out, and we end up with 5/3. Meaning then, if I want to take a look at the rate of change, or how I go from point Q to point P, I can go ahead then count from Q to P. I can go, again, if this is rise over run, then I can go from Q1, I can go up 5. So 1, 2, 3, 4, 5, and then to the right 3. 1, 2, 3, and I end up at point P. So that's the idea of our slope. It tells us the rate at which we're changing. So let's do the next one. Let's go, let's switch to an orange color here. Let's go through the point 3, -1. So 1, 2, 3, -1's here. So we'll call that Q2. Let's go ahead and again draw a line through these. And then we'll go ahead and say, all right, let's find the slope. So P sub Q sub 2. Okay. So since we have multiple slopes here, I'm still using the M as the abbreviation of slope, but I'm listing which points I'm going to go between. So as we take a look at this one, let's see, rise over run. So rise over run, let me write down the formula again here, y2 minus y1 over x2 minus x1. So if my P is my first point, my Q is my second point again, my change in y's are going to be -1 minus 3. And my changes in x's are going to be 3 minus 2. So that's -4 over 1. So my slope is -4. If I take a look at what that looks like, that would mean then that I would go as far as my rise over my run. I can abbreviate it to -4, or if I do rise over run, I'm going 4 in a negative direction. For every 1, I go in a positive direction. So if I come back over here to Q2, I can go down 4, 1, 2, 3, 4, and over 1 lands me down here. Didn't quite land me back at P, but what we can do is we can reverse these. If I reverse these, I can reverse both of them. So I can change it to 4 going up and then 1 going left. So I can move this negative sign from the numerator to denominator. And what that does is it changes 4 up and 1 left. So from this point here, let's see, 1, 2, 3, 4 up, 1 left. And then 1, 2, 3, 4 up, 1 left. I land back at P again. Okay? And so when we go back and forth between our coordinates, any point on a line is going to have that same ratio, so I can go forwards and backwards. So I can go on this first one here, up 5 and then over 3 to the right, or if I reverse both of these, okay, if I reverse both, that means I can go down 5 and then left 3. For originally we were going up 5 and right 3. If I do that same thing on this second one down over here, when I had a -4, I was going down 4, positive is going to the right. If I reverse both of those, then I'm going up and to the left. Okay? So because when we think about our XY axis, okay, we've got as far as our x and y's. Positive x's are to the right, and positive y's are going up. Negative x's are to the left, and negative y's are going down. And so that's one way that we can think about all of these. As we take a look at another example here, let's take a look at the 0.53. So since this is another example that we're doing, I would encourage you at this point in the video, go ahead and pause the video and go ahead and do line 3 and line 4 on your own and see what you come up with. Okay, so assuming you've paused the video and you're already back, you've got an idea of what we're doing, hopefully. Let's take a look at line 3 here. So we got the slope going from P to Q sub 3. Q sub 3 is going to be at 5 3s. So 1, 2, 3, 4, 5. And then up 3 is going to put us here. So there's Q sub 3. So going to be a nice horizontal line there. And so as we take a look at that one again with our rate of change, so another way to write this, change in y's over change in x's. So I take a look at my change in my y values. I'm going from 3 to 3, so 3 minus 3, that's going to end up being 0. And then as we take a look at our x's, going from 5 down to 2, so 5 minus 2 is 3. But 0 over 3 is going to be 0, okay? So that means we have 0 slope on this one. And any line that has a 0 slope will always end up being horizontal. That means then that I can go up and down 0. So going up and down 0 for every 3 that I go across to the right. If I reverse that, if I take the negative of 0 is still 0, I can take the negative of 3, so I could go up and down 0 for every 3 I go to the left. So really then I'm going up and down nothing for however many values I want to go right and left. So special case on that one. And the last one, let's take a look at slope going from P to Q sub 4. And again, if I do change in y's over change in x, let's see, my point is 2, 5, so that's going to be up here. There's my Q4. That one certainly appears vertical here. Let's see what the slope of a vertical line looks like. So a change in the y values, so 5 minus 3. And change in the x's, where the x's are identical, so that's 2 minus 2. So it's going to be 2 over 0. This one here, then, anytime we divide by 0, we say is undefined. Sometimes we'll see a 0 with a slash through it. It looks like the empty set symbol. Okay? And any vertical line will always end up being that style. We'll have a slope that is undefined. So taking a look at this example, we ended up with 4 different types of slopes overall. So on this first one here, M sub P Q sub 1, we ended up with a positive slope. We ended up with a negative slope. Then we ended up with 0 slope. And then we ended up with undefined slope. So a positive slope, this red line, is going up as we go from left to right. And we normally read here with English language, we read from left to right. And so as we take a look at that line from left to right, it is going in an upwards direction. It's positive slope. If we have a negative slope, take a look at that orangish yellow there. What that's doing from left to right is going down. So positives go up, negatives go down. 0 is horizontal, it's straight across, and an undefined is vertical. One way to try to remember these as far as the 4 different types of slopes, okay, think about skiing, okay? So if we are skiing, we might be doing some cross-country skiing or whatnot. We could go ahead and ski up a hill. My nephews live out in the west, out in Idaho and Wyoming previous to that. And one of the things that they got into was cross-country skiing. So they would ski up moderate hills, not huge hills, but moderate hills. You can turn your skis a little bit sideways or whatnot to get through there. But you can do that. You can ski slightly uphill. Going downhill is a whole lot easier. We see that on TV and whatnot. So going downhill, we have an example of something that's negative. You can ski on something that's horizontal. That's kind of the traditional thing we think about cross-country skiing or even water skiing. Water is flat. so it's horizontal, so we can ski on something of that sort. But if we take a look at that green line here, if you can't quite ski on something that's vertical. Either you've hit a wall, or you've run into a cliff, or you've fallen off the cliff, but you really can't ski on anything that's vertical. We have to have some kind of slant to it. Okay? So those are the four different types of slopes that we could end up with. Positive goes in the upwards direction, negative goes down, zero slope is flat, and undefined is vertical. So then we can do different things here with our slope. And let's take a look at a couple different examples. So in example 3, let's go ahead and draw a graph of the line that contains the point 3, 2, and has a slope on letter A of 3/4 and on letter B of -4/5. So again, one of the things I would do here is I'm going to go ahead and draw XY axes. I'm going to go through the point 3, 2. So that's going to be here. And I want a slope of 3/4. So a slope of 3/4 then, that means I'm going to go up 3 for every 4 I go across, because it's +3 over +4. Positive in the y direction goes up, +4 in the x direction goes to the right. So I'm going to go up 3 for every 4 that I go across. So I'm going to start at this point here, and then go 1, 2, 3, and then 1, 2, 3, 4 across. And I can do that same thing again. I go up 1, 2, 3, and then 1, 2, 3, 4 across. I can also reverse that. I could go, if I reverse both of those, so I did have +3 over +4. If I make it -3 over -4, well, the +3 meant to go up, the +4 meant to go to the right, -3 then means to go down, and -4 means to go left. So if I start with this point back up here again, I can go down 3, and 4 left, and end up back at that same point. Down 3, 4 left again. I can go down 3, 4 left again. Okay? And what I end up with is all these points are all on the same line. And that's something that this slope is describing, is how is this line changing? Okay? Let's take a look at letter B here, example B. Let's have a slope of -4/5. So -4/5, one of the things we take a look on that one, let's try to zoom in here for a second. Let's see if I can get, there we go, -4/5. This is an interesting item, because where's that negative? The negative is right in the middle of the numerator and denominator. So that would be the same as -4 over +5, which would mean down 4 and right 5. We could also put that negative in the denominator, which means that we're going up 4 and we're going left 5. So either way we want to look at those are going to be the same things. Okay? So let me zoom back out a little bit here. And let's see, so we're going to start at 3, 2 again. So start at this point. And let's go, let's see, down 4, right 5. So 1, 2, 3, 4. And then right 5. 1, 2, 3, 4, 5. I can do that again. 1, 2, 3, 4. Down 4, right 5. 1, 2, 3, 4, 5. Again, like I said, we can reverse that. So now let's take a look at this reversing here. I'm going to go up 4. 1, 2, 3, 4. And then left 5. 1, 2, 3, 4, 5. End up in the same spot. So 1, 2, 3, up 4, left 5, 1, 2, 3, 4, 5, and again end up at that same spot. So if I go ahead and connect that line, to get from any one point to any other point, I have to have that ratio of 4 and 5. So down 4, right 5, up 4, left 5. This black line overall, again, is black line overall. Notice its arrow is pointing up. It's going slightly to the right and to the up, so it has a positive slope. This blue line is going a bit downwards, and it has a negative slope. Part of the idea, positive slopes go up, negative slopes come down. Let's go ahead and reverse this a little bit. Let's graph the equation x equals 3. Okay? So if I graph the equation x equals 3, well, if we go back to our xy pairs that we did in a previous lesson, I know that x has to be 3. Well, what can my y be? There's no indication of y in this case. So since there's no indication of what y has to be, it can be anything. So let's maybe make it -2. X can be 3 and y can be -1. X can be 3, y can be 0. X can be 3, y can be +1. X can be 3, y can be +2. So notice what happens here then. It's a lousy line. Let's go ahead and clean this line up a little bit here. So when x is 3, 1, 2, 3, I could be at negative 2 for y. It could be at negative 1, 0, 1, or 2. Notice what happens here. We end up with another vertical line. So here's my x-axis, here's my y-axis, here's my line, x equals 3. And that line ends up being a vertical line. X value has to be the same all the time. Y value is the one that can change. So what else can we do with these? What we can do then is we can start describing other equations of lines using this idea of slope. So one of the first signs we come up with is the point slope form for the equation for a line. So we can see this on screen, an equation of a non-vertical line with slope m that contains point x1, y1 is given by the equation, we can see this equation 2 here, y minus y1 equals m times x minus x1. Now as we take a look at this theorem, one of the things that we see is this is a non-vertical line. It has to be non-vertical because if it's vertical, like what we had up here, okay, that equation is in the form of x equals just whatever number. So x equals a number, and that's going to be different from y minus y1 equals m times x minus x1. Also the idea on this one, if I take any two of these points and I take a look at the slope, well, if we take a look at the slope, that's y2 minus y1 over x2 minus x1. My difference in my y's, let's see, negative 1 minus negative 2, over the difference in my x's. Well, the difference in my x's is 0. So it really doesn't matter what my y value is. Now, in this case, it's going to be 1. But what that does for us, it gives us an undefined slope, and that will be a vertical line. Okay. So all of that's come back with to say, okay, we have this theorem for slope, the equation for a non-vertical line with slope m that contains the point x1, y1 is given by y minus y1 equals slope times x minus x1. We can see the picture off over here in figure 35, trying to illustrate that idea. Let me go ahead and show this by going back to the original equation for slope. Our original equation for slope is m equals y2 minus y1 over x2 minus x1. So we have here x1, y1, that's our first point. Then we have a generic xy here, and that one is our second point. So since that's our second point, we can go ahead and substitute, and we can say, well, let's see, let me back up here. So x2, y2 is now just xy. So going back into my slope formula, instead of y2, that's going to be just y. So I got y minus y1. Oops, I made a minor mistake up here. Or maybe it's just my printing. Whoops, y1 there. Over x minus x1. So instead of the x2, I'm replacing that with x. So now I no longer have those components. We have these items here, y minus y1 over x minus x1. But notice our formula. Our formula up here has no fractions. So one way that we can get rid of a fraction is we can multiply by the denominator. So we can multiply both sides by x minus x1. When we do that, the denominators cancel, and we end up with, and if I rewrite the multiplication, so we have, let's move the m to the left side. I've got m multiplied by x minus x1. This commutative property of multiplication says that we can change the order. So, and then we can go ahead and flip-flop the sides of the equation here. Y minus y1 equals slope times x minus x1. That is the point slope form for the equation. So all we have to have here is the slope and then some point. And what's our point? Our point is the thing that we were given here as far as x1, y1. So if I'm given any point and I know how I'm changing, I can go ahead and get to the next point that I want, and then I can also come up with the equation for that line. Okay? So let's go ahead and do that. Find the point slope form of an equation of the line with slope 4 containing the point 1, 2. Okay? So what do we know here? We know that we have a slope of 4 and we have a point. Our point here is the point 1, 2. So our point slope form, okay, has a point, got that, and a slope. We've got that. Whoops, moved around a little bit. There we go. So let's go ahead and write our equation out. So we got y minus y1 equals slope times x minus x1. We're going to do a substitution. So this is x1 and y1. And so see, so we've got y minus, let's see, y1 is here, that's 2, equals slope, which we said was 4. Clean that looks a little bit like a y, that's a little bit better. X minus our x1 was 1. Okay, so that is the equation in point slope form. Nothing else we have to do with that. If we're asked for the equation for a line in point slope form, that's it. Now, if we had a double negative in here, we could go ahead and change the double negative to a positive. But if we're just asked for a homework or a quiz or a test or something to write in point slope form, we can just go ahead and stop what I've got circled, and we're all set. If we go on to example 6, let's find the equation of a horizontal line containing the point 3, 2. Okay? So let's see, so we've got a point. So our point is 3, 2. We weren't told specifically our slope, but we were told that we have a horizontal line. If we have a horizontal line from previous, okay, let's scoot back up here a little bit. When previously we did this, our horizontal line was this blue line, and the blue line had a slope of 0. Any horizontal line will have a slope 0. So let's come back down through here, and we say, okay, well, since I know it's horizontal, my slope is 0. Oops, let me get back to the pin. Slope is 0. Now I can use this to go ahead and write my point slope form. So I've got y minus a y value equals slope times x minus an x value. So those x values and y values are x1, y1. So let's go ahead and fill in our values then. So we got y minus, let's see, my y value was 2 for my point. My slope is 0. I got x minus my x value of my point was 3. I can simplify this. I've got y minus 2 equals. Now, 0 multiplied by anything is always 0. So I got y minus 2 equals 0. That simplifies traditionally to just y equals 2. Anytime we have a horizontal line, it will always be of the format y equals some value. Just like a little bit ago, a few minutes ago, we had a vertical line. We can say x equals, I think we had x equals 3 previously. So we got vertical lines with undefined slope. So slope was undefined. Horizontal lines here with 0 slope. Just a couple of different items as far as what do these sorts of lines look like. The horizontal line will always fix our y value, and our vertical line will always fix the x value. Another form of an equation for a line involving slope that we very frequently come across is the one that most students remember from high school, and that's slope-intercept form. And that one says that y equals mx plus b. Let's again pull this apart just a little bit, and I want to go ahead and get rid of my rule lines here. So when we take a look at this one of the things that we can do is we can say, all right, so let me go ahead and say my y-intercept here. My y-intercept is b. Okay, my y-intercept is b. That means, if you remember from a previous lesson, whenever we have an intercept, the other value is 0. So the x must be 0, y value must be b. Okay, and then we have slope will just be m. Okay, so y-intercept of b and slope m. So we got a point 0b, and if we take a look at that, we could say, all right, my slope then here is, and let's go ahead and do this also. So let's put this here. This would be 0b, and let's then get some other point out here, and let's just call it a generic xy. Okay. That way I have 2 points I can use for my slope formula. So my slope formula change in y's would be y minus b over change in x's, x minus 0. So then if I start to simplify this, I get m equals y minus b over x, because x minus 0 is 0. And then if I want to get rid of my denominator, multiply both sides by x. That means my x's cancel over there on the right. So I have mx equals y minus b. And if you remember solving algebraic equations, if I want to move some to the opposite side, I go to the opposite operation. So I currently have a minus b. To get rid of the minus b, I'm going to add b to both sides. So if I add b, the minus b plus b go to 0. So I end up on the left side with mx plus b. The right side is y. Typically, we rewrite this and flip-flop the sides. So y would be equal to mx plus b, and that is our slope-intercept form. Because what do we have? We have our slope, which is our m, and the intercept we have specifically then is the y-intercept. So when we have those scenarios, then we end up with slope-intercept form. What can we do with these? All kinds of things. So example number 7. We've got a few more examples here. Find the slope m and the y-intercept b of the equation 2x plus 4y equals 8, and let's graph the equation. So my slope-intercept form is y equals mx plus b, where what's with the x is my slope, and then what's by itself is my intercept, and specifically the y-intercept. So if we can go ahead and rewrite 2x plus 4y equals 8, solve it for y, then by the positions of where the numbers are in front of the x and then by itself with y on the left side, then we can identify the slope and the y-intercept just from the equation. So let's start with 2x plus 4y equals 8. And as we go through there, I can go ahead and let's see, if I want to get the y term by itself, I've got to get rid of this 2x. Let's subtract 2x from both sides. So on the left side, 2x minus 2x is 0x. 0x is 0. So 0 plus 4y is just 4y. And then for the sake of argument, I'm going to put the minus 2x listed first. That way it matches more my format. Then to get the 4 by itself, I've got to divide by 4. I'm going to divide every term by 4. That way the 4's cancel on the left side. 4 divided by 4 is 1. So we have 1y, but 1y is just y. Negative 2 over 4 is the same as negative 1/2, so that's negative 1/2 x. And 8 over 4 is 2. 8 over 4 means 8 divided by 4, so that's 2. So now we have the format that we're interested in. Y equals mx plus b. Now we can match positions. So m, my slope, is going to be negative 1/2. My b value here, which is my y-intercept, is now going to end up being 2. Now that I have that, which was the first part of my question here, find the slope, did that, find the y-intercept, did that. Now we want to graph the equation. So if we graph this equation, let's see, we got a y-intercept of 2. So there's 2 and a slope of 1/2. Negative 1/2. So negative 1/2 means that I'm going to go down 1 for every 2 that I go to the right. So down 1 to the right is going to be here. Down 1, another 2 right is going to be there. I just kind of missed my points there. There we go. So that would be the equation for the line 2x plus 4y equals 8, because that would be the same equation as y equals negative 1/2 x plus 2. So we see our y-intercept there at 2. We see our slope is negative 1/2. If we take a look at this a little bit further, another thing we can do, let's see, let's move this around. Example number 8, let's find an equation of a line if we're given 2 points. So we found the equation of a line if we're given the slope and an intercept. Now we want to see if we can't find the equation of a line just given any 2 points. So as we take a look at this, we've got a couple different things that we can work with. So I've got point slope form. Let me write this off over here. Point slope form, which was y minus y1 equals slope times x minus x1. Or we could also work this out with slope-intercept form, which is y equals mx plus b. So either of those two that we want to use, we can use. We just get to choose which one. And so it really depends on which one you're more comfortable with. for the sake of class and example, we're going to do both. So if I take a look at point slope, slope-intercept form, one of the things that I notice is each one of these involves slope. The slope is nowhere given to us in the equation. However, we were given 2 points. Since we're given 2 points, we can find the slope. So let's see, regardless, I got to find the slope. So the slope was y2 minus y1 over x2 minus x1. Another common way to phrase that is a change in y's over the change in x's. So let's see. So I've got the change in y's. So I'm going to do 5 minus 3. So that's my 5 was my second y. 3 was my first y. And I do my change in my x's. So my second x is negative 4 minus my first x is 2. So 5 minus 3, is 2. Negative 4 minus 2 is negative 6. So my slope is going to end up being negative 1/3. So now, if I'm going to use point slope form, okay, I've got my slope. I need a point. So I can choose either of these 2 points that we want. I'm just going to choose the first point just for sake of example. So we've got y minus the y value, so y minus 3 equals slope. So negative 1/3 times x minus the x value, and the x value of that pair was negative 2. Was 2, so I get minus 2 in my parentheses. So the point slope form of this line that goes through these 2 points is y minus 3 equals negative 1/3 x minus 2, and that would be it. If I go back to try to find slope-intercept form, well, in slope-intercept form, I now know that my slope is, so we just did that, my slope is negative 1/3, but I don't know my y-intercept. So I'm going to have to find that. In order to find that, what we can do is I have here an x and a y in my equation. If I have values for x and y I can plug into the equation, then the only variable that I don't know is b. So where can we get these values for x and y? How about those first 2 points where we're given to us? So I've got circled in green up here. Let's do the point 2, 3. So 3 was the y value. At negative 1/3 x, let's see, x is going to be 2 plus b. So as we try to simplify this and solve for b, negative 1/3 times 2 is negative 2/3 plus b. To move that 2/3 over, I'm going to add 2/3. So add 2/3 to both sides. So 3 plus 2/3 is 3 2/3. So that's going to equal my b value. So that means I can rewrite this as y equals negative 1/3 x plus 3 2/3. That would be my slope-intercept form. Now that would be good for paper pencil. One of the things that we get into when we get into my math lab in our online homework system. So our online homework system is very specific and says write either integers for your numbers or fractions as our numbers. 3 2/3 is kind of a mixture. It's a mixed number. It's got an integer in it and it's got a fraction in it. So we would have to convert that then to an improper fraction. So we got negative 1/3 x plus. So this one we've got 3 times 3 is 9 plus 2, so we got 11/3. That item here, this last piece, is how our online homework will ask for it. It'll ask for it as 11/3. Okay? So what we ended up with, then, we've got an equation over here in green, we've got an equation in black. How do they relate to each other? They're actually the same thing. How do I know? Let's take this point slope equation here, and let's start solving this one. We'll solve it for y. So I got y minus 3 equals, let's distribute the negative 1/3 to both pieces inside the parentheses. So that's negative 1/3 x. Double negative becomes positive, so that becomes 2/3. Then if I want to get rid of this minus 3, I've got to add 3 to both sides. So we got y equals negative 1/3 x plus, see 2/3 plus 3 is 3 2/3. Oh, surprise, surprise. That is what we ended up originally on the point slope or the slope-intercept form. Interesting enough, when we take a look at these, there are an infinite number of points on any line. So there's an infinite number of variations of point slope form that we could use for a line. There's only one y-intercept for a line, so there's only one slope intercept form for the equation for a line. Generally speaking, what we do then is we tend to write things in slope-intercept form because it's less work to double check. There's only one variation of that item, only one item to check, and so that's where we would end up with. Okay. There are some other forms we're going to take a look at. One other form here is the general form of the equation of a line. That just means we put the x and y both on the same side, and whatever number we have, what we call our constant, gets to be over on the right side all by itself. Now, some general caveats on that one. We have to have real numbers, so normally that's all the numbers we would think. We'll get into imaginary numbers much later in the course. And a and b cannot both be 0. One of them could be 0, or the other one can be 0, but not both of them. Because if both of them are 0, then we have a times 0, which is 0, plus b times 0, which is 0. So you get 0 plus 0. The only thing that can be is 0. So c ends up being 0. So if a and b are both 0, everything is 0. And what fun is that? So we say that a and b cannot both be 0. So what do we do then in general form? Well, let's graph an equation in general form using its intercepts. Okay? So using its intercepts, going back to something we looked at earlier, to find the x-intercept, let's see, what do we have to do? To find the x-intercept, we let the y value be 0. And then to find the y-intercept, we said let the x value be 0. Okay? So whatever intercept we're trying to find, we're looking for the other variable to be 0. So if I let y be 0, then I've got 2x plus 4 times 0 equals 8. So 4 times 0 is 0. So you just get 2x equals 8. Divide both sides by 2. So x ends up being 4. That's my x-intercept. And the y-intercept, we're going to let x be 0. So we get 2 times 0 plus 4y. So don't need the y in parentheses here. It doesn't hurt anything. It's just a little unconventional. 2 times 0 is just 0. So I end up with 4y is 8. Divide both sides by 4 to get y by itself. So my y-intercept is 2. Interesting thing that if we were in class, I would actually go ahead and cover up the x value. So if I'm trying to find the y-intercept, if x has to be 0, I would just cover this whole thing up. Say, oh, that's just the same as 4y plus 8. Because if that's 0, I really don't care about it. Likewise, if I'm trying to find the x-intercept to let y be 0, I would just cover up the y term. Because then it gets 2x equals 8. I can do that in my head. It's just a simple division here. Graphing then, how many points determine a line? Only 2. And we end up with the intercepts here. So x is 4. 1, 2, 3, 4. Y-intercept is 2. Since I have 2 points, I can connect those. And there's my line. So the graph of 2x plus 4y equals 8 is right there. We graph it with the intercepts. And we can end up graphing that really relatively quickly. Because all we have to do is cover up the other variable and do a quick division, and then we end up with our intercepts. So wrapping this up a little bit, 2 more theorems real quick, one for parallel lines, one for perpendicular lines. If 2 lines are parallel, if you remember back from geometry, or just taking a look at, on a road, if we got on a road, you've got the white lines on either side, they're parallel to each other, they never touch, the yellow line in the center never touches. Railroad tracks, the tracks themselves never touch each other. Those things are parallel. So the 2 non-vertical lines, our official theorem here, is 2 non-vertical lines are parallel if and only if their slopes are equal and they have different y-intercepts. So what does that mean? What that means then is I've got to be going up at the same rate. I just go through 2 different points to start with. Okay? So if I go up at the same angle, hopefully it kind of makes some sense that they're never going to end up crossing each other. So what we can do is we can show 2 lines parallel by not even graphing them, but just taking a look at their slope-intercept form to find their slope and their y-intercepts. So if we take a look at L1 here, so line 1 is what that would represent, 2x plus 3y equals 6. Let's go ahead and solve this and put it into slope-intercept form. Okay? So that's the thing that we're going to want. Let's convert both of these into slope-intercept form. Then we want to see that the slopes are the same, but their y-intercepts are different. So that's a not equal sign there. So if I want to go ahead and get the y by itself, I got to get rid of that x term, so let's subtract 2x from both sides. So 3y is negative 2x plus 6. To get rid of the 3, right now I got 3 times y, so I need to divide by 3. So 3 divided by 3 is 1, which is just 1y, or y. And then we end up with negative 2/3 x. 6 divided by 3 is 2. So my slope then is negative 2/3, and my y-intercept is 2. Let's do the same thing for line 2. We got 4x plus 6y equals 0. And again, at any point through these videos, if you're trying to do this and follow along for class, I would recommend just pausing the video every once in a while before I finish the rest of the steps and see if you end up with the same thing. You might do a step or two different along the way, but our final result should end up being the same anyway. So on this one, I'm going to subtract 4x from both sides. So I get 6y equals negative 4x. We divide both sides by 6 then. 6 divided by 6 is 1, so we got 1y, which is y. 4 over 6 is a fraction, reduces by 2, so I still got the negative in there. So that's negative 2/3 x plus 6. I don't have a y term listed out there as far as the intercept, so it must have been 0. So that means then my slope is negative 2/3, and my y-intercept is 0. So that's the thing that we need to show that these two lines are parallel. Slopes are the same, their y-intercepts are different. Okay, so we can say line 1, there's a symbol for parallel, it's parallel line 2. Since they have equal slopes, but different y-intercepts. So then we can say by the theorem of criteria for parallel lines, the slopes are equal and they have different y-intercepts, so these two lines must indeed be parallel to each other. Take a look at example number 11. Find an equation for the line that contains point 2, negative 3, and is parallel to the line 2x plus y equals 6. When we take a look at that one, we can say, okay, well, if I've got to be parallel, then my slope must be the same. Okay? So my slope, an equation for the line, yeah, my slope must be the same as whatever the slope is here of 2x plus y equals 6. Okay? So slope has to match 2x plus y equals 6. I was distracted there for a moment because I'm taking a look at my screen and I'm not sure I'm recording any longer. So hopefully I'm wrong and I finish up these last few examples and I go ahead and say, hey, yeah, we are finished recording. So let's take a look. So I need to figure out the slope of this line. So I need to put that in slope-intercept form. So we can do that very quickly by subtracting 2x from both sides. So that's negative 2x plus 6. So my slope then is negative 2. That means the slope of the line that I want is going to be negative 2 also. But now I want a slope of negative 2, and I want to go through the points 2, negative 3. So let's see. I can go ahead and do that in point slope form, because that's y minus y1 equals slope times x minus x1. So that's y minus the y value of negative 3 equals the slope of negative 2 times x minus the x value, and there we go. That is the equation for a line that goes through the point 2, negative 3, and is going to end up being parallel to 2x plus y equals 6. So our last item here, criteria for perpendicular lines. Two lines will be perpendicular if the product of their slopes is negative 1. So if I have a slope, let's call it m1, and I have another slope, let's call that slope 2. If I can multiply those together and get negative 1, then I know the lines must be perpendicular. Now, if I take this and rewrite it over here. Um, so that's -1. And I solve it for m1. That means I would divide both sides by m2. So m2 would cancel out. So the slope of 1 is, let's see here, opposite sign. So one's positive, one's negative, and 1 over anything is the reciprocal. So another way to view these is that we are going to be perpendicular if the slopes are negative reciprocals from each other. So one's positive, one's negative, and they're flipped over. So for example, 1/2 and -2. Those are opposite terms. One's positive, one's negative, and they're reciprocals. We got one that's 1 over 2 and the other that's 2 over 1. I could have 3/4 and -4/3. Those would be opposite reciprocals. That means if those are slopes of lines, those lines are perpendicular. So let's find the equation of the line that contains the point 1, -2 and is now perpendicular to this line. So when we take a look at that one, let's see, I've got to find the slope of x plus 3y equals 6. So let's go ahead and subtract x from both sides. So my goal here is to put it into slope-intercept form, y equals mx plus b. So we got 3y equals -x plus 6. We divide everything by 3, and y is -1/3 x plus 2. So the key thing here that we're looking for is that my slope is -1/3. So if I want a slope that's perpendicular, that's the symbol for perpendicular. It looks like an upside down T. So I want the opposite sign of negative, which is going to be positive. I want 1/3 flipped over. So 1/3 flipped over is 3 over 1, which is just 3. So now I have my slope. So if I go back to point slope form, I now know that my slope is, and I've got my point. So y minus the y coordinate of that, so it's a double negative there, equals 3 times x minus 1. I could leave it that way, or I could rewrite it as y plus 2 equals 3 times, and the quantity x minus 1. And so there we go. We've taken a look today at section 2.3 on lines. We have taken a look at the definition of slope. We've graphed things with points and slopes. We found the equations of vertical lines, horizontal lines. We've taken a look at slope or point slope form as well as slope intercept form, and we ended then with parallel and perpendicular lines. Okay, so that wraps it up for today. If you happen to see a mistake in any of the material here, please drop me a line and let me know. Otherwise, we'll see you in the next video.